MGG-11.
Hey, good afternoon, everyone.
Good afternoon, sir.
Shall we start or just wait for some other people to join?
We should start, sir.
Okay, very good afternoon, everyone. We'll start. Okay, so although we do have a lot of things to cover, so which cannot be completed within 3 to 4 classes, I do understand, but I'll try and tell as much as I can. So we'll start with the Unit 9 data standards. I think a previous day we have discussed something about the georeferencing and what do we mean by a coordinate reference system. So coordinate reference system, I think I have given you different types of coordinate reference system. I was discussing about the projected coordinate system and the geographic coordinate system. So within a projected coordinate system, why it is basically necessary? So when you need to analyze the area or the length, so all these kind of things actually require you to go for a projected crs, I mean coordinate reference system. Now while the geographic coordinate reference system, the wgs 1984 that we are using right now, is basically for location purpose only. And it is much more accurate, and it do not distort the map now, because in projected coordinate system it tries to get the shape. Now if you have in your practical classes, you might have studied about projections, okay, so map projections, so where you might have studied about the Mercator projection. So the projected coordinate reference system is basically uses universal transverse marketer, so UTM. Right now, if you are staying in Odisha, so we basically follow 44N, UTM 44N or UTM 45N. Okay, so these are the things I will explain you how to create a vector data set and how to do interpolation and rasterize any vector data set that you right now is having. So georeferencing, I think I was discussing yesterday, that georeferencing means what? If you do have a paper map, or maybe you will be having some kind of data, so which need to be geographically fit. I mean, if you'll not have a coordinate reference system assigned to any kind of, let's say, image or raster file that you are uploading, then you can't simply overlay different things. Overlay, I'll come to what do you mean by overlay. Now, because overlay actually helps you interpret or analyze a lot of things. Uh, Based on that, we'll simply start with the data standards. What do you mean by data standards? And then we'll move to the creation. What are the different sources that you can actually get different GIS data, vector data, and raster data. Then I will explain you with hands-on session on how to create a vector file, and then how to interpolate a data, vector point data, and create raster files, and what are the different uses of different vector formats, I mean, or raster formats, how we can use for our study purposes or for research, how we can use those kind of data. Okay, so we'll be discussing on a very critical aspect of GIS, that is basically your data standard. Now, data standards basically what it does, it basically data ensures that no, the spatial data can be shared, used, or analyzed consistently across different applications. Now, without standardization, now data exchange and integration would be very much chaotic. So that may basically lead to inefficiencies and inequalities in decision making. So for better or informed decision making, we need data standards. Okay. So definition and concept of data standards. What actually mean the data standard? So in GIS, so data standard basically refers to a set of rules or guidelines and different protocols that basically ensures spatial data is structured, stored, and exchanged in consistent and interoperable manner. These standards define how spatial data should be collected, formatted, documented, or transferred. So this is what data standard is all about. Now, what is the importance of using data standard in GIS? Now, because GIS basically involves data from a lot of sources. I mean, you may you may do your own survey to collect different primary data, even different government agencies and research institutes, even private companies. So they do provide GIS data. So without standards, what will happen? Without standard, when you will be trying to integrate those data sets, it will be really difficult. That may lead to inconsistencies in projections, or even in attribute information, or even in metadata documentation. So let's suppose you do have and you have surveyed and collected the primary data from your study area or region of interest regarding regarding, let's say, slums. Okay, so within Bhubaneswar, you try to geo tag now which are the places which are basically having slums. Then within that geotagging, or maybe say files that has been created, so you will be assigning multiple attribute data or metadata, which we basically call. Now, attribute data can be population, number of households, what are their socioeconomic conditions, now whether they have access to safe drinking water, whether they have access to health facilities, and what are the economic and even the educational um, educational standards of people who are basically living in those small slums. So that is basically we you know what we include in attribute data. So attribute data need to be managed properly, and if we don't have any standard formats, then it will be really difficult to uh, really difficult to analyze, even interpret. Now, if you have collected those data and you really want to share those data, so you need to have standard GIS formats. unless and until you do have standard GIS formats, what will happen? You may share it in a different format, then other people may share it in a different format. So at the end of the day, what will happen? It will be really difficult for interpreting those data. So that is why we need to have data standards or GIS data standards. So for which we need to have data creation. Within data creation process, we need to follow some rules. Then data quality. Within data quality, now what is the spatial attribute, what is the logical attribute, and what kind of attribute data we are basically including. Then a spatial reference, I mean, what kind of CRS or coordinate reference system we are basically using. So that should be standard. If you are using, let's say, WGS 1984, so which is the standard or default CRS for any kind of vector file that you are creating out of your local computer or a desktop GIS. Even within a raster creation, mostly the default CRS is basically WGS 1984. So which is basically the geographic coordinate reference system. Now, how, in what data standards basically help? It basically help you in data interoperability. Okay. Now why? Now because it allows different GIS softwares and systems to work together seamlessly. Unless and until, I can give example of, let's say, Photoshop. Okay, Photoshops do have their own formats. Okay, so with its own extension. So just like that, the vector file formats like, say, file, GeoJSON. So all these are basically they are basically standard vector data formats. So if you you will be saving some other kind of vector formats, so which are not supported by, let's say, standard desktop GIS softwares, then it will be really difficult for someone else to access it. Now because we are so much used to using, say, files or GeoJSON or geo packages. So all these kind of data are basically standard vector formats. So when you do have standard vector formats, you can simply use uh, different uh, different desktop softwares or even cloud computing software. So not cloud computing softwares, but in the cloud that you can process. And even using a different programming languages, just like, Python really helps. Now because there are a lot of libraries in Python, so which or packages which basically helps you to manipulate the GIS data. I mean, for vector data formats, you do have Sepli or Geo Pandas. So Geo Pandas, they are really powerful. I mean, if you do have a lot of data, then the programming language is the only solution that you can actually look into. You do have raster packages in Python, just like rastorio and gdal. So Fiona. So all these kind of libraries are basically helping us to manipulate and to do different tasks in GIS data formats. So if we don't have any data standards, then what will happen? You may not use these kind of things. The software is basically used for that. Now just like I was giving example of Photoshop. So if you do have a, let's suppose, some kind of peculiar image that is not supported by Photoshop software, then what will happen? You may not edit or manipulate the photo or the image. So you need a standard format. Okay, so either you should be having an image or the Photoshop file, or the or the Photoshop formats that is basically being given by the Photoshop Adobe, uh, Adobe company. So that you need to follow. That is basically the standard procedure to manipulate anything or to edit or to process any image within Photoshop software. So just like that, in GIS, you need to have different standards. You need to have, coordinate reference system, that is basically spatial reference. You need to, maintain a data quality. You need to have, a different data creation process, so that it will be easy for any kind of analysis and documentation. Data accuracy and consistency also matters in data standards, so that is why you need to follow data standards. Now, ensuring that spatial data sets maintain uniformity so across different projects. Okay, so even if you do have data standards, what will happen, it will be future proof. I mean, um, it basically support archiving or retrieval of spatial data over a period of time. Now let's suppose you do have zip files right now. So zip files and geojsons are basically popular vector file formats. Now if you are saving something or archiving something for the future generation, they can they can um, access these kind of data, and they can interpret now what has happened, and they can study or they can do research on this. Now maybe in future what will happen, different other kind of formats will uh, take the place of these kind of data formats, but they will be the standards at that period of time. Now right now geo package is really getting popular now, because so files do have its own limitations or shortfalls now, because in the metadatas are basically stored in different files. So whenever you are transferring vector files within no using save files, what will happen, you may misplace some metadata, so that will create inaccuracies. So when will be even you will be interpreting those kind of save files in other softwares now other than your computer. Now because if you are accessing from your own local desktop, then what will happen, you can easily access it and you can process it, so that will not be a problem. Now while if you will be missing some metadata within say files, then what will happen, it will not open properly, it will show inaccuracies. So I'll show you that. So spatial data format standards are basically that basically includes SEP files, that is basically .shp, then GeoJSON. GeoJSON is basically a lightweight format for encoding spatial data, and using JavaScript it is really and most of the people who are using JavaScript, they basically prefer GeoJSON. KML data is basically used by Google Earth. Okay, so if you will be exporting any kind of data out of the Google Earth, then it will give you in KML file. So which is basically keyhole markup language. Okay, then GeoTIFF is basically a raster data format that embeds geographic metadata, and GeoPackage. So GeoPackage is basically the modern open standard for spatial databases. So these are the data standards or format standards for GIS. Then CRS. So we have discussed about the data standards of the formats. Let's get into the CRS. CRS is basically coordinate reference system. So spatial data must have a properly defined coordinate system to ensure that all data sets align correctly on the Earth's surface. Now, most of the widely used CRS are basically WGS 1984 that I was giving example. So the code for it is EPSG 4326. So which is the global standard for GPS based positioning. Then UTM. So that was a geographic coordinate reference system. UTM is basically projected coordinate reference system. Then NAD 83, NAD 83. So North American datum 1983. So mostly it is used in North America only. Even you have Indian datum. So Indian datum 1975. So mostly used for mapping in India, and it is basically used by Survey of India. Then what are these are the CRS standards. So what are the metadata standards? So metadata basically provides you essential information about a data set, including its source, purpose, accuracy, and different limitations. Now, some of the important metadata metadata formats are basically Federal Geographic Data Committee, so metadata standard. So basically used in the US for geospatial data documentation. Then you have ISO 19115, then DCMI, so which is another general metadata standard applicable to GIS, Dublin Core Metadata Initiative. Data quality standards. So within quality standards, you will be having positional accuracy, how close a mapped feature is to its true location, that is the positional accuracy. Then attribute accuracy, so the correctness of non-spatial information which is basically associated with a data set. Then logical consistency, so ensuring that spatial relationship are basically maintained. you know Roads are basically properly connected, or river banks are basically properly connected. Then completeness, so which is basically the degree to which all required data is included. Okay, so data exchange and interoperability. uh, no since no GIS is often shared across different organizations, and basically used by different individuals, take into account the researchers, take into account the government organizations. So the data exchange standards must, so need to be compatible. Okay, so for which common standards basically include WMS, so which is basically web map service for sharing maps across the web. Then WFS, web feature service for sharing feature data across the web. Okay, and then WMTF TS, which is web map tile service for sharing pre-cased map files across the web. Then WPS, WCS, or CSW. So all these examples has been given in your note that you can actually look into. So what are the different challenges in implementing data standards? And first of the challenge is basically your lack of awareness and training. Most of the GIS user are basically unfamiliar with proper data standards. So that when they don't have much idea about what are the different standard formats, what are the quality standards that is basically being followed, what are the spatial reference standard that has been followed. So all these kind of no kind of things, if some users they don't have idea, then that basically lead to a challenge for implementing GIS. Okay, then second one is your inconsistency in data collection methods. Now let's suppose you have used a different file formats for collecting different data. So when you will be archiving any kind of data, then what will happen? So this will basically lead to a lot of, so this will basically lead to inconsistency. Now because some file formats are basically different, and other file formats are different. Then when it comes to when it comes to interpretation, then it will create a lot of problems. Okay, Then even software compatibility issue now, because some GIS softwares may not fully support open standards, so it becomes really difficult for making data exchange difficult. I mean, for data exchange you need to have some standard formats that is being supported by the desktop versions of GIS. Okay, so now let's suppose you do have a software so which do not support the zip file format. So if it do not support zip file format, then what will happen? Then you'll find you will have to convert it to some other format which is basically being supported by your software that you are using. So in that case, it will create some nuisances. It will create some problems. Okay. Then topological models in GIS. So topology is basically a fundamental concept in GIS that basically defines spatial relationship between geographic features. Now, unlike simple, a vector model that store geometric information, but topological model go a step further by preserving relationships like connectivity, adjacency, and containment. So if you need to analyze the connectivity, then you need to go for the topological model. Now, although the vector file formats do have topological model within it, I think I was discussing about the spaghetti model. uh, we have discussed some vector file formats and what are the different models which are attached to the vector file formats. I think we have already discussed. Then connectivity. So connectivity basically refers to how a line feature, a line is basically an arc. Okay, so how line feature in GIS dataset are basically linked to each other at different nodes. Why this is essential? Now, because there it is essential for network analysis. Applications like road network or river networks or utility networks, so that is why you need connectivity. Okay, so in connected networks, line must share common endpoints just like nodes. Here you can look into this example, arc node topology. So all these pinkish kind of points that has been shown here. So this is basically a drawn schematic drawn by, I think, the contributors Dr. V Sivakumar and Professor Bijay Kumar Baraik. So all these are basically one, two, three, four. The pinkish points are basically nodes. Okay, and the lines between them are basically arc. So which is basically arc node topology. Okay, so this how it basically this helps. Now this basically helps in network analysis. Here you can clearly see that now if this is a road, this is a road, so all these are basically roads. Then you can look into the points which are basically essential for any kind of policy implication, or if you are planning something. So then this kind of network analysis is really essential. um, Now what are the different applications of connectivity? So it helps in transport uh, networks. Just like you need to find out the shortest routes or the optimal routes to reach from one place to another. Then even connectivity uh, is basically used in hydrology modeling. Now because modeling river networks and water flow, uh, that in that case connectivity actually helps. Then utility networks, just like designing any electrical or sewage network. Now you need to plan for the drainage networks. Uh, then connectivity function comes into play. Area definition, what do you mean by area definition? So it basically states that an enclosed polygon must be formed by a series of connected arcs. So that is the area. I mean, here, yes. Okay, so here, basically those points in line or arc are basically nodes. Now here it is basically a vertex or node. So a vertex is when you do have a single point. Okay, so node is basically different than a vertex. So you do have two polygons that has been shown here. So this is polygon 1 and this is polygon 2. The connected vertices are basically referred as nodes. Okay, so and always remember that when we'll be creating the polygon or polygon shapes, I will show you that what do you mean by these kind of vertex. Now because we'll have to give different points and the arcs between them or the lines between them, so which is basically joining these two vertices. So when they will be enclosed, that will define the area. Now because for polygon 1 this is the area, for polygon 2 this is the area. So if these two polygons overlap, then you may have a transitioning zone. Contiguity or adjacency, so that basically refers to spatial relationship between adjacent polygons. So it ensures that neighboring polygons share a common boundary. So that is contiguity. So that is what I was explaining. So if uh, these portions will be overlapping, then what will happen, this is basically the contiguity. So here it has been written properly. Okay. Now why is this schematics has been actually drawn, hand drawn. I don't know why they haven't given direct examples from on the GIS softwares. Now why it is essential? Now because it helps in spatial analysis. It basically helps in zoning, land use planning, and different demographic studies. In topological models, contiguity is maintained using the left right rule, where each arc knows which polygon is on its left or which one in its right. So that is basically left right rule. Topological relationships in GIS. Uh, there are mainly four uh, here, I think six. Okay, so I think to my knowledge, there are mainly four topological relationships. First is your contiguity, so which is basically uh, adjacency. Now, when two polygons share a common boundary, so that is contiguity that we have already seen. Then containment. So containment is basically one feature is entirely within another. So that is basically containment. Now you can take example of a lake within a national park boundary. So that is basically containment. within properly within the uh, within another kind of zip file, I mean polygon. Then connectivity. So when features are basically connected at nodes, that is basically connectivity. And intersection uh, is basically when features overlap or cross each other, that is basically intersection. So here you have different uh, topological relationships that has been given. Overlap, which is we think we have already discussed in contiguity. Then touch, examine whether two geometry touch at their boundaries but do not intersect. So intersect is something different. So when we assess whether interiors of the geometries intersect, equal determine spatial equality of two geometries. Okay, I think examples has been given here. Equal topology relationships. Okay, points. So multi points. So these are equal topology relationships. Then you have intersect. Intersect means, when now let's suppose you do have a, a line feature. So you can look into this line feature. If some point is basically intersecting it and you want to retrieve some data from the line feature, then you can simply retrieve it. So that is basically intersect. So here within these are the point. Okay, so point and multi-point intersection examples has been given here. Then line and point intersection has been given here. Here you do have line and line intersection. Now because if one line is intersecting another line, then it has been given here. Even you can have a multi-point and polygon intersection. You can have line and polygon intersection. Then comes your disjoint, overlap, disjoint. Okay, so disjoint means, I mean, when one point is not in touch with other, that is disjoint. So you can have polygons, points, a point and lines, then polygons and polygons, lines and polygons, then line and line. So this is basically disjoint. Okay, so these are basically disjoint. Now because here it has been given an example of point and polygon. So this polygon is in not in contact with this point. So this is a disjoint. Then you have overlap topology relationships. Overlap is basically contiguity. So here polygon contiguity. So in which you will be having a shared or transitioning zone. A touch. Now when it basically touch at the node or at the vertex or maybe at the outer part, so then that is basically a touch. Okay, so you will be looking into these kind of examples. So once we uh, create vector formats, then we'll be looking into it. Then within which I think I was giving example of I think, you know whosoever has written it, I think two or three uh, two or three examples has been given more now, because intersection and within contains, so those are basically same kind of things. Okay, anyway, the six topological relationships has been given here, so we'll be looking into it. Okay, then cross topology relations. So this is same kind of thing. I mean, this kind of thing can be considered even in intersection also. Then what are the different topological rules in GIS? So to basically enforce spatial integrity, the different GIS softwares like QGIS and ArcGIS, so they implement topology rules to prevent data errors. Now these rules basically ensures that spatial features do not overlap, and they do have gaps and or even misalignments. So that is basically the topology rules. Now some common topology rules basically includes they must uh, every arc must be enclosed by two nodes. So especially its beginning and ending node. Now let's suppose you do have a line, then it must be it must be enclosed by two nodes. So I think we have already discussed what we mean by node. So here we have one node and another node is here. Then rule number 2, each arc is bordering two polygons, left and right polygon. So each arc, so when you do have any arc, so it should be or it must be bordered by two polygons, left polygon and right polygon. So here it has been given. Okay, so you have a polygon here, you do have a polygon here, so this is the arc. You do have a polygon here, you do have a polygon here, and this is what a arc is, this blue line. Then each polygon have a closed boundary that is made series of nodes and arcs. So this is very clear from the very start that I was discussing that polygon has a closed boundary, so they cannot be left open, and now because that will not be considered as a polygon. Then a sequence of arc or polygon alternates and cycles around each node. Okay, arc intersect only at their boundary nodes. What are the applications of topological models? So, topological models are widely used in urban planning, transportation, even environmental modeling, and other GIS applications. So, uh, what are the different, in network analysis, so mostly finding shortest path in road network, optimizing routes for emergency response service. Then within land use and cadastral mapping, so maintaining accurate property boundaries, then ensuring zoning compliance. Hydrological, within hydrological modeling, simulating river networks and watersheds, then analyzing flood risk zones. Then ecological and environmental studies also use topological models and different topological rules. So they basically define protected areas and wildlife corridors. Then they basically identify deforestation patterns. So all these basically follows topological rules. Now I think now whatever you are listening right now, so it will be really difficult for you if you don't actually have studied GIS in your UG days. It will be really difficult for you to understand what you mean by GIS, and now what are these kind of terminologies. So all these kind of terminologies will be basically jargons for you. Now, whether I am right or wrong, that you need to decide. But to my knowledge, if you don't understand or if you haven't studied GIS and studying GIS for the very first time, understanding these concepts can be really tricky, and understanding these kind of concepts can be really difficult for a very newbie. I mean, you haven't started the fundamentals, and if I'll be speaking a lot about the advanced concepts, it will be really difficult. I do understand that. So even during our UZ days, I do remember I haven't now we haven't studied GIS now, because it was not in our course. So anyone, you can even put a message, anyone who have actually studied GIS in UG. Okay. So it may seem difficult at first glance, but it's not that we are actually discussing very difficult concepts. Now these are kind of easy things unless and until you do go through different practical exercises. Now I'll suggest you to search different YouTube videos, then look into install ArcGIS or QGIS on your laptop if you do have, or on your desktop if you do have. Then um, uh, then play with it. I will simply suggest you to play with it. So how to create raster files, how to create vector files, then how to interpret different data, how to georeference any data, then how to create or how to download um, different GIS data formats. Okay, so we'll at the end we will go for one practical exercise of creating data sets and how to analyze. Now, because your block 4 is all about um, uh, just a minute, guys. Acha.
ହଁ ଏଚଡି ଗ୍ରୁପରେ ଗୋଟେ ସେରି କରିଥିଲେ ସେଠି ଦେଇ ଦେଇଛନ୍ତି ତାପରେ କହିଛନ୍ତି ଚୁଜ୍ ଫ୍ରମ୍ ଏମଡି
Okay, sorry for the disturbance. Okay, so we'll discuss on data acquisition. What are the different sources of data that you can download different types of data, existing data, creating new data. So we'll complete this exercise also. And first let's discuss where from you can actually find different types of data. Okay, so let's get into the EDAS Imagine. So EDAS Imagine is one of the softwares popularly used for manipulating raster files, and it is one of the most accurate um, it gives higher accuracy whenever you are classifying images into, let's say, land use and land cover mapping. So these are the areas which are having um, different types of land use classes. Then Survey of India do provide you uh, DEMs and even vector data. I will show you here. Survey of India. Now, if you'll get into Survey of India data downloads, so here under downloads within Survey of India, you can look into different types of data which is basically being provided by the Survey of India. Now, if you need to go for let's say Survey of India zip file download, then you can also search it. Then look for Survey of India digital products. Okay, so within digital products you do have topographical maps. So if you'll be providing toposit number, so you can download it in a geo database or even in zip files. Okay, so even in zip files you can download different toposit maps, but it is paid. I think you'll have to pay somewhere around 7,000. Then you have other products, digital vector databases. Okay. Administrative boundaries are basically free, so you can download the zip files for the whole country. You can have state boundaries, you can have district boundaries, you can have even up to village boundaries. I mean, block boundaries are also available, then village boundaries are also available. So you can click here, you'll have to register yourself, you sign in here, then you can download these data for free. I have already downloaded. I will show you how you can also download. So here ORI and DEM. So DEM data is also available, and ORI and DEM is free. Okay. So but the product code, and this one, and this is basically having a higher resolution. So that is why you need to pay for it, or else DEM data is also available. Geo-referenced color raster, one toposit, so you'll have to pay 1,000. Now, this is not actually needed. I mean, if you have, the PDF copies of toposit, so that you can actually download, and you can geo-reference it. So that will be your, in TIFF format, you can save it, and that will be your geo-referenced uh, toposit. Okay, so if you need a georeference toposit or color raster, then you don't need to pay here. You can simply download it freely and georeference it yourself. So these are basically some kind of the village boundary dataset is also available here. You can simply click here. Now the price is 0, so you don't have to pay anything. Here, look at it. The open series map free PDF is available. So you can download this PDF and georeference it yourself, convert it into an image format, then you can download it. So these are different data sets which are available in the Survey of India. Then America View, USGS Earth Explorer is one of the very important sources. You can look into it. Let's look into the USGS Earth surface. Uh, Earth Explorer, USG. So this is the user interface of USGS Earth Explorer, where you can actually download a lot of files. I mean, a lot of data is available here online. So all you have to just register yourself. So all the data, most of the data are basically free. You can download it, unless and until it is very finer resolution data set, and you can easily download it. Here, what you can actually do, you can upload one of your save files, then it will show, or even you can search different uh, okay. So if you want to download data for India, let's suppose I want to download data for Odisha, so then you can come to India here, then zoom in to your desired location. Based on your internet speed, it may take some time. Is it visible whatever I'm showing? Okay. So let's suppose I want to download data for this region. So what you can actually do, you can you know create a polygon like this. So let's suppose these are the regions I basically want data for. So once you click it, then you can give the shape, or else you can actually add a shape file here. You can simply upload your shape file here. So that can also be done. Then simply click on data sets. Now here, within data sets, you do have different categories of data sets which are basically available. So for aerial imagery, you can look into what are the different aerial imageries which are available for this region. Then you can look into, this data set is not this is basically a commercial data set. These commercial satellites, Econos, then Orb-View 3. So all these satellites actually do provide you very high resolution data set, but it is paid, and you'll have to pay. Uh, you can download digital elevation model, and digital elevation model, within digital elevation you do have SRTM. So all these, okay, so all these data sets are basically freely available. So you can use this SRTM 1 arc second global, so which is of around 30 meters of resolution, and you can download it. Okay, so within land cover, you can also download some of these, um, land cover maps, global land cover characterization, land cover trends, and geotag. But Landsat is really popular. All the Landsat data are can be accessed from here, and this is basically used by a lot of people for assessing or for studying, for doing research. So Landsat data, it is available from 1984. So we can also look into Landsat 4 and 5 thematic mappers. Even let's search first. Okay. Okay. So let's see results. So which are the data sets which are basically available within Landsat 8 and 9 OLI. Operational land image. Think we'll search for only this data set. Let's see. Okay. So now these data sets are uh, here. We can look into the footprint. Okay. So so footprint, within so footprint, it will basically show the tile that is covering the area. So if you really want to load the image, then you can load it here, and it may take some time. Here it has loaded the tile, so you can look into the image that this tile is basically having. Okay. So then you can look into the metadata and browse it, then you can download it. Okay, from here there is a symbol download. So you can download the satellite image from this website, usgs earthexplorer.usgs.gov. Okay. So this can be easily downloaded, but you need to log in first. You need to register yourself. It is completely free. Then let's see the footprint. So this image basically covers the whole of the region that we have actually selected. So when we'll look into it, so what is within it, we can clearly see. Okay. Okay, so here you can clearly see the river properly, so which is basically captured by the Landsat image. And these kind of white patches which are basically seen all around are basically cloud covers. So in satellite remote sensing, this is one of the biggest demerits of this kind of data acquisition. Now, because if the cloud cover is really high, then it will be really difficult to analyze different sorts of data. Okay, so this is one kind of data, and let's get into data sets again, and we'll select some other data. Let's look into the digital elevation SRTM data and look for the results. So within digital elevation models, you can right now select the digital elevation model. So we'll look into the footprint first. So it is not covering the whole of our study area. This is also not covering this whole. So you'll have to download different DEM or digital elevation models to basically access this. So first, what you can actually do, now you'll have to download these four tiles. Four tiles. After downloading the four tiles, then what you can do, actually you can merge it. That is in technical terms in GIS, mosaic. Okay, so raster mosaic. So these are basically raster tiles. So these raster files can be mosaic, and once these are merged, then you can simply clip your study area. Okay, so American View, Ohio View, US Census Bureau, then Natural Resource Conservation Service, Montana GIS Clearinghouse, Federal Geographic Data Committee, Geospatial One Stop, okay, geodata.gov, then landcover.usgs. And now, if you will be looking into the USGS Earth Explorer, so all the data, the soil, the geography, the land cover, so all these can be accessed. Okay, so here are different platforms. First one is Google Earth. Google Earth, where you can actually download different data sets. Okay, so then you have Google Earth. I think Google Earth is really easy, and even you can download it on your mobile. You can download it in on your mobile. So Google Earth product is easily available to every one of us, and you can even you can search online what do you mean by Google Earth, and you can look into, you can look into different features which are available to us by Google Earth. Okay, so here also you can add a path or polygon. You can add place marks, then measure distance and area, and even use historical imagery and time lapse to see how the globe has changed over. So what are the changes that has occurred? here in this, let's suppose here in this region, 2009, this is 2010, 2011, 12, no major changes is basically been seen. We'll look into what Bhubaneswar. Okay, so now you can clearly see the built-up areas are basically increasing with each year it is increasing. Now you can clearly see these are basically all the built-up areas of Bhubaneswar region, and it is slowly and steadily expanding outwards. Okay. You can look into these regions. Okay, Birla Global University, some hospital, and look into the built up areas in these regions. But in 2008, now if you'll get into 2015, you can clearly see these areas are having a lot of built up index, and these areas are also being exploited in 2020. Now, right now, it is now even more. Okay, so Google Earth can also be used for remote sensing purposes. Right now, I am studying this region, this Satkosia Gorge region, the incision and nick point migration of this Satkosia Gorge. So this is where Mahanadi River cut through the Eastern Ghats. So this is basically your Eastern Ghat, and Mahanadi River cuts through this Satkosia Gorge. So you are having Satkosia Tiger Reserve also here. So this is from where your Mahanadi Delta starts. Noraj, I think, Noraj, from Noraj, then your delta. So this is basically your delta. So these are whole of deltaic regions. All these are basically delta regions. Then Bhuban, I think Bhuban is a really popular uh, site for all the Indians now, because uh, you can easily download different types of data sets are basically easily available in Bhuban, and Bhuban NRSC hosts at the even thematic maps. Okay, so you'll have to register yourself, and uh, here you can look into what is the national geospatial policy now, because after that it is providing you free data sets. Okay, so right now the the list for data is freely available. You can look into what are the different themes of data that you want. If you want thematic visualization, then you can also look into it. Just click in thematic within bhuban.nrsc.gov.in, so where you can look into land use, land cover classes. For different years are there. You can look into it, and you can download it easily. You can uh, let's say 2019-20 of this region. So this is basically Bhubaneswar. So that is why the built up index is really high. All these red patches are basically, so 1920, let's say 2023, 24. You can look into different geological features. Let's suppose geomorphology. and 2005-6. Only the 2005-6 geomorphology is available. So geomorphology data can be downloaded. Uh, Select state. What is okay? So it is basically loading the geomorphology of the whole of Odisha. It is taking a lot of time, so we'll look into the Bhadrak only. Okay, it is taking a lot of time. So you can also explore other kind of datas. So list 3 and list 4 datas, then Kato DEM data is also available. Uh, Microwave data. So microwave data is available from 2021 to up to 2024. Now this came into existence because of this national geospatial policy in 2019, I think. uh, Government decided to provide different data sets for free. Okay, so then digital elevation model that I think I was discussing about the subtle radar topographic mission SRTM data is available in USGS Earth Explorer. Then even Aster DM is available there, or you can simply search it. Then you can easily download it. You'll be getting this global DEM GT GTOPO 30, and it is approximately 1 kilometer resolution. But I think Aster DEM and SRTA DM are more than enough to do any kind of survey. So for these are four vector data formats that you can easily download from different sources. Then what are the different vector data sources? You can look into the Survey of India. I think we have already discussed about the Survey of India. Then Diva GIS, I think I was explaining yesterday about the Diva GIS. Some SRE products. Then OpenStreetMap is another popular databases, so which is available free of cost to us. Okay. Okay. So let's get into creating a vector file, and how can we use interpolation in creating raster formats that we'll be seeing here. So this is basically kind of practical for you. uh, I'm using QJS. You can use ArcGIS or QJS. Okay, I'm just adding one of the base maps so that it will be really easy for us to follow what we are actually doing. Now let's suppose I want to digitize the river banks of this region. Okay, digitize the river banks of this region. So for digitizing the river banks of this region, so first I need to create one of the shape files, and I need to use the line function. Now because for banks, let's suppose I want to digitize this bank. Okay, so the left bank, and want to digitize the right bank of the lower Mahanadi basin. So this is the Satkosia gorge. And after which, if I will be digitizing this, then what we can do. So first we need to create a vector layer. Okay, so here, you can new shape file layer. Here is the function to create a new shape file layer. Click it. Just name of the file, I will save it on the documents, maybe data, uh, polyline or river bank. Okay, so I am naming it as a river bank. Okay, then encoding I will leave as it is. Geometry, so within geometry you do have different things. So you have a point, multi-point, line, and polygon. So point, line, polygon are the three features that we'll basically be using. So first, let's create one of the lines first. So within line, what we have already studied, it will be having arc and nodes. So you can complete with one node, sorry, two nodes, so within one arc. So that is fine. So this is basically the CRS that I was talking about, uh, the coordinate reference system. So here you can look into different types of coordinate reference systems which are available to us. So this WGS 1984 is basically uh, geographic coordinate reference system, WGS 84. Here we are using it. No, uh, EPSG is the code, EPSG 4326. Then this is the authority ID, and even you can use UTM to UTM zone 45N. Okay, you can look into where this UTM zone is basically falling. So it is covering most part of the Odisha. Even look, you can look into 44, not 44. 45 basically best represents this the parts of Odisha. These parts mostly. Okay. 44 also represents 44N and 45N. So based on your requirement, you can define it. But I am not going to define it. I'm leaving as it is. This is basically the default CRS or default geographic reference system which is available to us. Then I can simply go and click OK. So it will basically give me one of the shape files. So first of all, I need to digitize the river bank. Okay, so for digitizing, now let's suppose I am zooming in here, and first I need to start toggle the editing. So once I toggle the editing, so I do have a feature called add line feature. Why? Now because the river bank we have selected the line feature. So here I am basically selecting add line feature. Then you can see just click based on your requirements. So with each click, it is basically defining the river bank. Okay, so likewise I am basically digitizing the left river bank of lower Mahanadi river. Okay, so when I basically double click it, so it will ask what ID I am basically I will be providing to name this feature. So I'll give 1 or 0. You can start from 0 also. Okay, so 1 is basically defined this region. Now let's suppose in the right bank I want to digitize another polyline. Okay, so it will ask me to give an ID, so I'll be providing two. So I do have two different uh, polylines, so which are basically defining the left bank and the right bank of the lower Mahanadi river after just the Satkosia Gorge. Okay, so what I can do, I can simply save it, save the layer edits. So I can simply save it, then I can toggle off the editing, in that way you don't no mess around. So what will happen, we have already okay, so we have already created our two polylines. So what we can actually do here, um, we can change the color and see, then let's just increase the width of the line so that it is easily visible. Okay, so here we have digitized these two lines. Even if you you know close the Google satellite imagery, you can clearly see that these are the two files that we have actually created. Okay, so this is the right bank, so which is basically ID2, and this is basically ID1. Now you can also look into the attribute table. Here we do have two IDs. So the left bank is ID1, so which is basically getting selected once I click here. Then ID2 is basically the right bank of lower Mahanadi river. And if even if now, because this is basically geo referenced, even if I remove this layer and add another base map from let's suppose the OpenStreetMaps or Google Maps. So within Google Maps also, you can clearly see, just let me just, okay. Okay. So from the Google Map itself, you can clearly see that it is actually in its original geographic position. So if I will not assign any coordinate reference system, then what will happen? These lines will not be overlaid in its actual geographic position. So in a way, what will happen? To if we don't have these lines in properly coordinated, then what will happen? So these they'll not simply be overlapped. Okay, overlaid over here. Now overlaying, basically, I think I was giving example of overlaying. Now let's suppose I want to add, not GSI, okay, India and states, where I do have the data set for Odisha. This is Odisha, the districts of Odisha. I can, you know, okay, Odisha boundary. Okay, so here we can look into the different CEF files that has been imported. I think Odisha already done district boundary, state boundary. Okay, so Odisha districts, I am just zooming in the layer for Odisha district. Then I'm just toggling off the district boundary for the whole of India. So these are basically the districts of Odisha. Okay, so we can clearly see it, and even we'll assign the levels so that you can see which are the different districts. Okay, so these are the districts. So if now also I will zoom this to this layer, we can clearly see the right bank is basically of Cuttack district and the left bank is basically of Nayagarh district. And we have digitized these banks. Okay, so here we can look into uh, we can clearly look into this, that it is aligning well with the actual actual geographic positions of uh, actual geographic positions, sorry. Okay, so we can look into it. Then you have the whole district boundary. I think we can toggle it on and zoom to layer, so you can see. So these are all the districts of whole of India, and you can clearly look into any kind of state, any state, and let's give a different color to the Odisha so that it is easily visible, and we can clearly distinguish. Okay, mm, let's toggle off the levels. Okay, so this is the Survey of India dataset that I have already downloaded to my local computer. Here, we can clearly see that this is the whole of India, and this is Odisha. So this is Odisha, and the Odisha district boundary is perfectly aligning with its own geographical location. Now, if I will simply toggle off this and look into the geographical boundary of Odisha, and if I will be adding some base maps, then you can simply overlay it. I mean, look at it. Okay, just a minute. Now you can clearly look into it. Now these are the districts. So this is Mayurbhanj district, your Balesore, Bhadrak, and this is Keonjhar, Sundargarh district. So all these districts are perfectly aligning. So your this is Keonjhar district. I think these are the mining regions. These are the mining regions. Okay, where iron ore is basically extracted. Now, why this is happening? You know, if I am basically adding any base maps, now why it is happening that, it is basically the state boundary is basically overlaying on its actual position. Now, because it is geo-referenced. Now, if we'll be looking into the properties of the Odisha vector file, so which is basically a SEP file. Now we can clearly look into it that it has followed LCC WGS 1984. So WGS 1984 or WGS 84 projected. It is not geographic coordinate reference system. This is one of the projected coordinate reference system, and this is basically followed by the Survey of India. So different metadatas has been also given here. And if we can look into the attribute table, it will be having district level safe length, and also the districts. Yes, here. Okay, so all the district names has been given, then state names has been given, ID, some kind of ID has been given, and the area and the length of the districts has also been given. Okay, so this is how we create polyline. I mean, this is the river bank polyline. I think we have already done this one. Then how can you create polygons? Now let's suppose I want to add a polygon into it. Then we can simply name it as polygon. So what polygon is all about? Polygon is, a closed uh, area. Okay, so we are living as it is, so it is basically following the default CRS, coordinate reference system. So now let's suppose I want to just digitize the uh, the Chilika Lake. So it is, although it is not closed here now because this is basically a sandbar. Anyway, so we'll just use this as one of the polygons. So I have already added the polygon here. Then you can toggle on the editing feature, then add this polygon. Then you can start from here, then start digitizing it. Now always remember, whenever you are clicking something, it is basically adding a point, so which is basically a vertex. Okay, so this is let's just, actually I have done that for another vector file, so that is why I have just deleted that. Okay, so here is the shape that actually the shape is not that good, but here is the shape that I have digitized, so we don't have much time. Then you can simply save here and toggle off the editing. And right now, if we can no brush, okay, and give some different colors to it. Let's keep it yellow and see it. Okay, so so now you can clearly see the polygon feature that we have already created. This is the polygon feature, so which is basically representing the Chilika Lake over here. So within this, you can clearly see that it is really spatially aligning well, but my digitization was not that great here, so that is why it is some inconsistencies are there. But you can but it basically serves the purpose of showing what a polygon is. Now even though I will simply remove the Google Maps and Google satellites, but we can clearly see where Chilika is with reference to Odisha map. Okay, so this is clearly visible and this is clearly seen. And like that, you can simply look into different points. So you can create a new shape file give it the geometry of point, then you can simply add different points to it and then save it. So in a way you can see different points. I think I was discussing about uh, creation of raster layer using interpolation. Okay, interpolation. Okay, some point files are actually here. Can let's have a look. Yes, yes. Okay, so different points are there, and each of these points are basically representing rainfall values actually. So I will show you how to create raster. So simply using IDW technique. So IDW interpolation I will be using. So here are rainfall points and a value, it is the value, then I will simply add it, then extent. First of all I need to add the Balangir. Okay, so calculate from layer Balangir, then click on run. So what it does, now you can see these are clear pixels. Okay, so you can see these are clear pixels, and each pixel will be having some values. Some you can also define the resolution of it. It is also fine. I mean, okay. Let's move this one to top. Sorry. So in this way, we can clearly see this one, and we have created this raster file. So within this, you can see the red areas or the red. Now, because when you are having the point data, you are basically having some trouble analyzing or interpreting the rainfall. So here you can easily see, these areas are basically having low rainfalls, and the blue regions. So blue regions are having high rainfall, and these orange color mm, squares are basically, or pixels are basically showing moderate rainfall. Okay, so this is how raster is basically being created, or you can even create a new raster. So I'm not saving anything, and so this is it for today, and I'm dropping my email ID if you really need any help regarding anything relating to GIS or remote sensing. You can write me an email. So thank you everyone. If you want to ask any questions, you do have any doubts, then you can ask. Okay then. So I'm leaving the platform then. Thank you everyone.